Sophie. I'm from Montreal, where I work as a developer, and I organize also the Ruby meetups. We built, that's not good. Okay. We built that project as a team. This is my friend Giz. He co-founded a video game studio that created PewDiePie and H3N3 video games. And we both qualify as adults. I want to make that clear. So this is not sliding as it should. Is it? Okay, I'll figure that out. Do you remember the Pokemon cards? Who owned some of them? Do you remember the special ones with holographic designs on it? How cool they were. So in the video games, there's a similar concept. Oh, nice. Now it's sliding as it should. Okay, there's a similar concept in video games. Pokemon was spawned with different colors. We call them shiny Pokemons. And some people are very serious about catching them all, like my friend Giz. In the last Nintendo Switch game, like other games, there's some Pokemons that rely on exchanging items that you have in limited amount, like fossils, or other Pokemons. And you have a limited quantity of them. You have to find the right NPC, start a dialogue, press A, press A, press A, press A, press A, over and over again, and then when you have nothing left to exchange, you reset the game without saving, and you can start again. The odds of finding a shiny Pokemon is 1 out of 4,096. So it can be very, very time-consuming. This is my favorite slide of the deck, because it's literally what we're planning to do. I present to you the project Trash for Team Rocket Automated Shiny Hunter. For automation to be possible, we need to solve the input and the output. We need to press A with precise timing in the right sequence and reset the game when needed. We need to stop the robot when a shiny is found. To control the game, we have many options, destructive and non-destructive, or have the potential of be accidentally destructive. We went with servomotors because they're cheap and easy to find, very safe, and we can control them really easily with an Arduino. For the input now, the only place in the process where we need to make a decision, like a conditional, is when we want to know if the Pokemon is the right color or not. When the Pokemon appears, it's always centered on the screen. It doesn't move much, so we can use a single pixel, check its hue, to see if it's a shiny Pokemon or not. So we decided to go with a webcam because image quality is not that important. We just need to position it right, take the right pixel, and check the hue. Before, some people ask, no, we did not want to use machine learning. It would be incredibly cool, but exactly like using my microwave as a hammer. So we have a plan, and we need to make it reliable because it will work for several hours at a time. Unsupervised, we need it to be precise, easy to code, and configurable. To make it reliable, we glued the servo motors on a case that we made that is a snug fit for the Joy-Con. Just so you know, we only need to press 3 buttons for the entire sequence, which makes it really easy to make. It must not move the controller either, yeah, I told Arduino is controlling the servo motors. Fine, we can have a sequence program on the computer. Now, computer vision. To use the webcam, we used an open source project called Motion, which is really easy to install on any Linux machine or Mac. we can stream the image to a web browser, so we can monitor and take the right pixel, the one that we need. It's very useful if you want to set up monitoring for any project like an aquarium or a roof garden, anything you want. Motion is very, very useful. We can also grab a still image via an HTTP call, make it easy to analyze one single pixel. And we also decided to prefer false positive to false negative. For obvious reason, it runs for several hours. We don't want to miss a Pokemon, and we just want to restart the robot when it has a false positive. To code, we decided to use the Ruby language because it's the one, it's my favorite ever. I'm very efficient with it, but also there's plenty of libraries to interact with everything that we need. ImageMagick for image processing, also Firmata, which is a firmware and communication protocol that we can use to communicate with the Arduino. So the entire sequence is run on the computer, not on the Arduino. And both parts are tied together within the same script, which is amazing. I created a Rails app, just because I can, to configure the robot, timing, everything, even the hardware pins on the Arduino. It was also easier to set up for my friend, which knows some programming but is more efficient with an interface, and that makes it easier for other people to build a robot for themselves. Everything is stored in the database. Better experience. To put it all together, now, this is version 2 of the robot. We use the Raspberry Pi inside so we can use our computers instead of leaving it there for hours and not be able to work with it. The Arduino is connected to the Raspberry Pi, the webcam as well, and is now in a nice enclosure that I can show around. We added also LEDs to make it pretty. I could maybe fit a battery in there too. That's for another project. Now we have a prototype, and it worked for a few iterations. So we put it to the test. It has now around 200 hours of operations, and we had other challenges. Some hardware failed. The motors, the servo motors, broke. We changed brand for one that is more reliable. We also have implemented new features. We added new buttons in the interface to be able to perform certain operations like resetting the console instead of doing it manually, raising the arms to be able to release the controller, simplify updates, everything. And also, thanks to Twilio, which is here, the robot is sending us text messages when it finds a shiny and sends the image as well, which is really, really cool to show at work. And now, there's some improvements that we want to make on the robot, like calibration process easier for other people to be able to build theirs with their own hardware. We want to improve the robot's timing to be able to do more iterations per day. And we also want to be ready for the next Pokemon game, of course. Shield and Sword are planned for late 2019. We are going to be ready for that. If you want to build it, everything is open source. The hardware is easy to find. I have tutorials on GitHub. The source code is all there. Yeah, you can make it. You can also modify it, improve it. You can add lights and lasers, because why not? You might want to replace the Arduino with the Raspberry Pi's GPIO pins, which will simplify the hardware. One part it would be removed. We can improve the interface because right now it's ugly, but it works. Or you can adapt the code base for another game. So, thank you. And this is the list of the open source projects that I used. I I will make a demo during the breaks. Ask if you want. I don't have time to do it right now, but thank you very much.